5.5, additional identities. So this is a wonderfully theoretical. That's all this is here, at least this section about something called the product to sum formulas and sum to product formulas. We'll discover that in a bit here. But anyways, let's go over it here. So we studied this right here, this little part right here before. So we're going to expand it out by adding a few little extra things to that right there. And so can we evaluate this without the use of a calculator? I'll let you guys write down the problem here first, and then we'll go for it together here, and then we'll look through the, I wonder what if you do this, what happens? Identities. All right, so the difference between what we did before is this little plus sign in the middle here. So we're taking two angles that we don't know. We know the ratio of one of them is 3/5 for sine, 2 for tangent. We're going to add them together, and then we want the tangent value of it at the end. And so before we get started here, how about this? How about we just name these angles? This is what we're going to do. We're going to say this is sine of, this will be our angle A, and that just becomes angle B. And here's our problem. We have two angles that we don't know. We're going to try to add together. That's a problem for us, because then we don't know what the result angle would be in the first place. Then we need the trig formula of it. But do we know any formula that involves sine of A plus B? I think we do. Can you give me that formula?
Sine A cosine B plus cosine A sine B.
Sine of B cosine B plus cosine A sine B. I think that gets us out of our problem right there. So now we just need to figure out what is sine of this angle here, then the cosine only of this angle here. Good, we just kind of partitioned it up so it's now individualized angles here. So let's go on to the next piece here. So let's do this here. Let's just label this guy as A. We already did as A. Let's make a triangle based upon this right here. Let's make a triangle based upon this. The reason for it is because I eventually want to know, this is my angle A. Oh, hold on, look at this, look at this. This is sine of A, and this is sine of A. So I already know that. That's going to be 3/5. We good? That I already got. The problem is this cosine of A. I don't know what that is unless I make myself my little triangle and I work with that. This one definitely needs a triangle to work with because I just know tangent. And I'm trying to get cosine of B and then sine of B from that tangent value. Okay, so let's go for it here. On the next slide here, I'm going to make myself my little triangles here. Here's my right triangle. This will be angle A. And since sine is 3/5, I think I have 3 here, and I have the 5 here. And let's see, angle B. Oh, actually, we should know this one right here, right? Good there? Everybody with 4? Then we have angle B. There's that one. Let's see, sine. Oh, that's tangent. Tangent was 2. Same thing as 2/1. So I'm thinking opposite side over adjacent side. So everybody okay with 2/1 on a right triangle? Anybody give me the hypotenuse? Square root of 5, I think so. This is be 2 times 2 is 4, plus 1 more makes 5. Take the square root. I think we're all good there. Everybody okay with square root 5? And at this point, we're done. Let's plug stuff in that we know. Cosine A, sine of B. That's from the previous slide, and we can put stuff down into it. Sine of A, we know that's 3/5. That's easy enough. Cosine of B, anybody? 1 over square root of 5. I'll go with that. plus sine cosine A. Or 5. And then sine of B. And easy enough. I think we got this. It's 8 5 root 5. And eventually we got an 11 5 root 5. That's cool. All this cool stuff here that we're finding out. Okay, one for you guys. Exercise 2, very similar here, just for you guys to try. I need, yep, absolutely.
So even though it's arc sine, that doesn't matter. Like on the original.
Right. Those are the same, first of all, right? Arc sine, and you say sine inverse, those are exactly the same. Second of all is you assume these are in quadrant 1 already because they're positive. If they were negative, then this would go into quadrant 4.
Okay.
And this would also go into quadrant 4, but because they're positive, you know, we're in quadrant 1. Good question, folks. All right, all yours here. I need to know cosine, tangent inverse of 1/2 plus sine inverse of 1/2. This was kind of interesting because that's second inverse function, sine inverse of 1/2. We know that angle. We can actually figure out that angle, right? The problem is that tangent of 1/2. I don't know what that angle is, right? So there's no way to sort of compute that angle, add them together, and take the cosine of it. So we got to go to these extreme measures. Unless use a calculator. But what fun is that? Okay, go for it. Look at example number 1. See if you guys can do example number 2. We good? Based upon that information, give you guys about a minute head start. All right, I'm going to start as well here. So this guy is going to be cosine of A plus B. All right, if that's the case, this formula is cosine A cosine B minus sine A sine B. Tell me if you guys agree there with that one. Addition formula for cosine. Yep. Okay. So now let's start these little triangles here. That's right triangle A, and sine is 2/1. Triangle for B, sine is 1/2. Square root of 5 again, is that right? Up here? Oh, this one's going to be, that's a root 3, right? That is a, anybody tell me, what is that, 30, 60, 30 or 60 angle?
Wait, on the On triangle A,
Uh-huh.
isn't it?
The other way around?
Yeah.
Okay, let's go the other way around. 1/2.
Yeah.
Thank you. 1/2, triangle B, correct, and then this one is 4 minus 1 is 3. Take a square root, you get square root of 3. Perfecto, I think we're good. Let's go with it. Cosine of A is 2/5. Agreed, disagreed? Cosine of B, I think it's going to be what's square root of 3/2. You guys talk to me here. Is that making sense so far? Any questions? Need to slow down or not? Plus minus sine of A. (1/5). That's right. How come I'm not picking on people here? I love picking on people here. Let's see. Start with the left side of the room, the right side of the room. Corinna. Sine of B. Yeah, that's already given right over here, huh? That was easy enough here. And finishing it up here. Think at first the 2's can be go away. Everybody okay with that? Oh, you know what? No, I don't want the 2's to go away. Hayden, how come I don't want the 2's to go away? I can cancel off these 2's right here, right? How come I don't want to do that eventually? Ultimately. Something about common denominators. Yeah, because there's nothing, there's a little 2 right here, nothing to cancel, so I'm gonna have to bring them back anyways in order to put these guys together. So let me, yeah, it's kind of funny fraction, but let me keep it just like that. So I'm gonna keep a 2√3 on top, 2√5 in the bottom. 1 times 1. Adrian got excited or something like that. Oh, gotcha, okay. All right, this one's a little bit more of a funny answer here. This is gonna be a 2√5 on the bottom. On top, I have a 2√3 minus 1. I don't know what that angle is, but I know at least know the cosine value of that angle. Okay, we good? Okay, well, that's one piece. So this is us using addition formulas, difference formulas, other formulas, because we've built these up in chapter 5 to get what we want out of stuff. We good? One more, this one. So write the following as an equivalent expression only involving x. So another little piece in trigonometry is to get rid of all trig functions whatsoever. So what I want to do is I want to make this right into an algebra function instead. Or what I want to do is I just want to correlate to one side. So I want to say, okay, if this is what's happening here, one second, class. I messed up. This should be just an x. Can't have, that should be an x there. So tangent inverse of x. So get rid of trig functions here, or what I do is I want to correlate it just have an x. So then I have all the tools of algebra at my disposal at this point. If I can translate them to just involving x values. So let's think here.
So it's just 2 tan -1 of x.
2 tangent -1 of x, yeah. All right. Let's see. I'm not adding anything, so I don't need addition formulas. I don't need division formulas here. So I guess maybe let's do this here. Let me go with my little triangle still. This time I'm going to call it theta. I don't need A and B because I don't need to differentiate between 2 different angles anymore. Just one single angle. How about this guy being x, opposite over adjacent? So x is x over 1. Can you guys give me the hypotenuse here?
square root of x squared plus 1.
I go with that. Let's see. In order to get a hypotenuse, don't we need to square this guy? So it's x squared. We need to add square 1 and then add it together. So it's x squared plus 1, and then we have to take the square root of that. Are we good there?
Can't that just be?
Ah, good, good. Brenna's asking if this could be x plus 1. It could be if it was like this. Actually, no, it still can't be, because even if you factor this down, it becomes x plus 1, x minus 1. Can't. Only time you can reduce a square root in this fashion if it was like this. And then these two would cancel, that leaves us with x plus 1. Good question. You guys, please ask me the questions. That's what we're here. Okay, erased. Correct, yeah. The reason, that's where the issue is, right? Because you can have it like this right here, right? But that is not the same thing as, actually I should write it like this. That is not the same thing as this. Because if you FOIL this out, you get that little extra piece in the middle. That's the problem. Okay, we good there? Whew. All right, questions answered on a Friday. Yeah, any day, not just Friday. So hold on real quick, if we think about this here, this little piece right here, right there, isn't that just theta? So this turns out to be just sine to theta. Because I have that little 2 there. If it was just sine and then tangent inverse, I would do exactly what I did in chapter 4. Right? That would have been easy. That little 2 gets stuck. And I can't take the 2 out either. There's no way to take the 2 out. Oh, unless I have a double angle formula for sine. Awesomeness. Anybody give me a double angle formula for sine? Oh, let's see, 2 sine, yeah, a cosine a, in this case it's theta, so it's 2 sine theta cosine theta. I am done. This is so cool. Let's go with it here. So 2 here, sine theta. Let's see, bugging people as we go. Amaya, sine theta.
X over square root of x squared plus 1.
I'd go with that. Haley, cosine theta.
1 over the square root of x squared plus 1.
Perfecto, awesome. Okay, and then I'm going to just multiply this together. Now in this case, we got 2 square roots multiplying each other. That's awesome. I can get rid of those. And I have myself something that does not involve a trig function. This is a rational function from algebra. Now I can start adding this together. I can do something called a derivative if I need to look at it in calculus. But what I've done is I've made all this based upon that little side angle, that little side value. So then if I need to increase it, decrease it, all this stuff stays in proportion. I get to see what I need. And that's actually the sine ratio. So based upon this, I know the sine ratio. And I can make it bigger or smaller, however I want. That's cool. Okay, we good there? So this is the in conclusion of chapter 5. We have stuff involving inverse trig functions that are a higher level than we did in chapter 4. Now, let's go with things that make us ponder. Oh, I should say this. This is going to be the development of the sum. I think it's the sum to product. Product to sum formulas. These are not the formulas. We're just going to generate them here. So I'm going to put
those aren't the product
derive.
sum formulas.
No, I'm going to put like this. We're going to use those to derive them. That's a V. So these guys here are stuff we know. This is the sum and difference formulas. So talk to me, anybody. I'm going to grab these 2 right here. And what I want to do, just take those two formulas and I'm going to, I guess, add them together. And let's just subtract them. Let's see what I want to do here. I think I'm going to subtract. Yeah, let's add these two formulas together. And this is one of those, I wonder what happens if. All right, I should say this here on page 194 and 195. This is kind of cool. Your book did a 2 pages of all the formulas all the identities that we've made so far. We good? That was kind of cool. So there's, if you want to refer back to a page number. Okay, so as Grant stops clicking the pen, we're going to go with Rylan. If you do this here, if you put this stuff together, I think you're going to get this here. Sine of A plus B. I'm going to add it with sine of A minus B. And what's going to cancel? You guys remember this is like algebra. Do you guys remember algebra when used to do this here? It was like 2x plus 4y is equal to 8 and 3x minus 4y equals to 7. Do you guys remember that? It's called the elimination method. No. Maybe? Vaguely. Oh, wow. So yeah, you would do it to get rid of one of the variables, right? You'd add two full equations together because what happened was that gives you the 5x and this goes away. And it was like, oh yeah, that's cool. X equals 3. That's awesome. We're going to kind of do the same thing here. We're adding these two formulas together. This I just added. It's down here. And with this stuff, it looks like 2a sine A cosine B and another sine A cosine B. Hold on. If I add these guys together, that would give me this right here. What's going to happen on the other side?
Cancel.
These guys are gone. They cancel out. So then all we're going to do, one more thing we're going to do, because this is called a product to sum formulas.
Wait, can you explain why they're gone?
Yeah, just because one's a plus, one's a minus. So when you add these guys together, they just disappear on us. And then let's do this here. Let's divide both these guys by 2. And so what we have is, this is the formula from the textbook here. It's 1/2. Actually, can I write it the other way? I'm going to go like this here. This is the way the book is right. This is sine of A times cosine B is equal to 1/2 in big old blocks here. Sine of A plus B plus sine of A minus B. Let's see what time we have. Boom. Okay. So, nice. There, is that good? It is. Okay. So this is one of those, hey, I wonder what if. So let's try some other ones here. Let's see what happens here. We're going to just derive them. I think we'll just derive them today. So Monday we'll finish up the use of them. Okay, so I got those two. That was kind of fun. Let's do this here. How about, you think things can cancel here? So this is the first formula we have. That's been the first formula for us. We're going to see if we can get probably 3 more maybe out of this. Hey, all right, let's do this here. How about these? Can we add these guys together? Will things cancel? Yep, can you guys do that? Same process, same thing. Let's add them together. Divide by 2.
Wait, so the sine A cosine B is the product of sum formula?
Yes, right here. That's the product of sum formula.
Like, is it of sine or of cosine, or is it just
No, it's just a product of sum formula. And you would say, if you do see sine of A multiply cosine B, we can use that as the formula.
How often in like application problems does it end up working out nicely like that?
As far as deriving things, it should always work out nicely like that. As far as using it in application questions, I haven't found a use for the product of sum formulas in applications. It's just a theoretical thing. So let's go for it here. So hopefully you guys added this together. Cosine of A plus B. We're adding it, right? Plus cosine of A minus B. And what cancels here? I think it's this stuff right here, right? This stuff at the end. So I don't have enough space here, but I'm going to write on the next slide here. Let's see if we have cosine of A plus B. You guys have to help me out here. Minus, we're subtracting, right? No, we're adding together. Cosine of A minus B gives us okay, everybody agreed. Is that true? So these are the ones that disappeared on us. We're left with two of these guys. And we have something that looks like that. And I think we have the same thing here. Divide by 2, divide by 2. And then let's write it the way the book does it. I'm going to flip this over to this side here. So cosine A, cosine B is equal to 1/2. Okay, there's my second formula. So now my question is there any which way to cancel anything else off? So let's go back to what we had before, letting you guys write it down. So let me erase again. So I added this one together, I added this one together. Out of curiosity, can I add these guys together? Just out of curiosity. Will anything cancel if I did this? Yeah, one's a cosine A, one has cosines together, right? And the other one has, oh, that's not gonna work, bummer. Okay, how about if I did this and this? Will that cancel anything out? Ah, same problem, right? Same problem. The cosines have them the same signs multiply together. That's no fun. What should I do? What should I do? Oh, hold on. How about this? Let's take the first ones that we did before. And instead of adding, how about if we just subtract them? So it would be off to the side, it would be sine of A plus B minus sine of A minus B. This is subtraction of these guys. Can we do that? Can we do that in algebra? Do you guys remember doing like if these guys were the same, if this was a plus right here, right? What you can do here is you can, instead of adding, you subtracted them. That was, it was called the, it's still called elimination, but instead of adding, you subtracted. So it would be 2x minus 3x makes negative x, 4y minus 4y goes away, and 8 minus 7 is 1, divide through by -1, and you're like, yes, cool, x is equal to -1. Same process as just the subtraction piece. So you guys talk to me here. If this whole piece is now being subtracted by this whole piece, what do we get? So minus sign here, the minus sign kind of goes into this piece right here. That changes into plus. Oh yeah, this stuff cancels, huh? Is it good? The front side cancels now. The back side now has a plus inside it. Let me write it the long way just so we can see it here. If I were to write it the long way, it would be cosine B, go back and forth here, plus. So that whole piece subtracting this whole piece. Sine A cosine B minus cosine A. If you went it the long way. If you saw it already, that's cool. If you didn't, then let's see what happens here. This is minus sine A, cosine B plus cosine A, sine B, and these two front ones are gone. Left with 2 cosine A sine B. All right, we're good there. And this is all equal to all right. Da, 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 da. Perfect. Cosine of A sine B 1/2. Okay, our third formula. Boom. Good there. Can you guys by yourself, can you get the last formula? Think about what needs to happen. I'll write down the formula, see if we match up. So let me go back to here. It's going to be the subtraction of these guys right here. You subtract these guys from each other and see what happens. That one. Cool. Sorry, Aiden, all good now? Sure. All right, with a little bit of time to go here, let's see, it'll be the subtraction of these two right here. So this minus this, subtracting this minus this. So cosine of A plus B. So let me write down, that's the subtraction part. And let's see, this minus this, subtracting this minus this. That's weird. Let's see. That's true. These guys go away, is that right? So in this case, this is a minus. Is that a minus? Minus A, sine of A, sine B, and this is also a minus? Way weird. I got minuses now. Okay, so then if I do this, this will be 2 of them, right? This will be negative 2 sine of A, sine of B. Okay, how do I deal with that? Let me go on to the next slide here real quick here, this one. So I have cosine of A plus B minus cosine of A minus B is equal to negative 2. Tell me, is that what you guys have so far? Cool. Okay, I don't like negatives, first of all, so I'm going to divide this through by negative 2. So the negative is going to go here, the negative is going to go here. So how about this? I'm going to divide this by negative, so that's going to change it up to a negative cosine of A plus B plus cosine of A minus B. We're good. We change the signs here. Are we good there so far? And switch it around.
Negative 1/2 and then the brackets. Just put cosine.
Gotcha. You could, most textbooks, I'm not sure if all textbooks, what they do is then they do this, they go 1/2 and they switch these around. This is the only time you have something that's switched around. The positive value goes in front and it's the cosine of A plus B on the back. It's the strangest thing with these formulas, this happens. It's kind of like, you know, when elements freeze, right? They're usually heavier, right? So they go to the bottom. Right? So like, yeah, that's the universal rule. Of course it happens, right? And then with water, it freezes and it actually gets lighter. It goes on top. So therefore, that's the only exception to the rule. All of them are exactly the same way, except for that little piece right there, which allows living organisms to still stay living during winter. Yeah, underwater. Okay, we didn't get to our exercises here. I'm going to stop there because we're past time. We at least derived the 4 sum or product of sum formulas. Good to go?
So do we have
Wait.
enough to do 5.5?
Well, I mean, we haven't done the sum to product formula.
Yeah, haven't done the sum to product formulas here. I think we'll have to wait. Let's see, you guys can start on homework up to the first part that we did. Up through 20. Whatever the homework is, up through 20. We can at least do those. All right, have a good weekend. You guys enjoy. We'll come back, finish up 5.5 on Monday.
Thank you.
Huh?
Have a blessed day.